Hello bachcho and welcome back. Don't worry, today's topic is very simple and also very important for your exams. We are starting Unit 2, Electrostatic Potential and Capacitance. Chalo, let's begin.
Today, our goal is to understand the idea of electrostatic potential energy so well that you will never, ever forget it. Trust me, this concept is the foundation for understanding energy in electricity, and after this explainer, it's going to be crystal clear. Your exam marks are safe on this topic. Okay, to get our brains warmed up, let's start with a simple question. Something to get us thinking. So why are thunderstorms so powerful? I mean, really, where does all that energy and the lightning come from? Have you ever thought about it? That incredible flash of light, that deafening sound, it can't just come from thin air, right? It has to be stored somewhere before it's released. Well, it's all about energy that is stored, just waiting to be released. What happens is the clouds build up this massive amount of potential energy compared to the Earth, and when that stored energy is let go, bam! We see it as lightning. So today, our mission is to understand exactly what this stored energy really is.
All right, now to really get this idea of stored energy, let's use a super simple analogy. It's something you already know from class 11, so it'll be very easy to connect. Think of it like an electric hill.
Okay, look here. On the left, we have a normal hill, just like in your gravity lessons. You do work to push a ball up that hill, right? You're fighting against gravity. Now that work you did, it doesn't just vanish, it gets stored as gravitational potential energy. Simple enough. Now, look at the right side. This is our electric hill. It's the exact same idea. Here, you do work to push a positive charge towards another positive charge. You're fighting against the repulsion force. And guess what? Just like with the real hill, the work you do gets stored. But this time we call it electrostatic potential energy. See, it's the same logic.
So, to complete this picture, if we have an electric hill, then what is electric potential? Well, it's nothing but the height of that electrical hill at any point. That's it. A higher potential simply means a higher point on our imaginary hill. And that means more energy is stored there for every unit of charge you place.
Okay, so now that we have this simple hill idea in our minds, which is great for understanding, let's look at the official NCERT definition. This is the exact language you need to use in your exams, so pay close attention. So NCERT says, we can define electric potential energy difference between 2 points as the work required to be done by an external force in moving, without accelerating, charge Q from one point to another. Now, I know that sounds a bit heavy, a bit formal, but don't worry, it's just the proper scientific way of saying what we already know. It's the work you did to push that charge up the electric hill.
So let's put it in the simplest possible words. The energy difference is just the work you did to move the charge. That's it. The energy that gets stored is equal to the work you put in. Nothing more, nothing less. Bilkul simple.
All right, let's break this down into 3 logical steps. This will help you remember the process perfectly. Okay, step 1. An electrostatic force already exists between the charges. It's a conservative force, just like gravity. Step 2. We come along and apply an external force to do work against that electrostatic force. And finally, step 3. This work that we did, it doesn't just disappear into thin air. It gets stored as potential energy, which we call U, in the entire system.
Okay, theory is fine, but let's see a tiny example with some numbers. This will build your confidence for the numerical problems in the exam. Dekho, this is very easy. Imagine we have a charge, Q, which is plus 2 coulombs, and we move it through a potential difference, delta V, of 10 volts. Remember that delta V is just the height of our electric hill. So, how much energy did we store? Well, the work done, or the change in potential energy delta U, is simply Q times delta V. So we just do 2 coulombs multiplied by 10 volts, and we get 20 joules. That's it. We have stored 20 joules of energy in that system. So simple. Okay, now for a very important part. This is something that can save you marks in the exam, so please listen carefully. Let's clear up a common mistake that I see many students make.
So, here's the trap. The wrong idea is to think that the potential energy belongs only to that single charge we moved. Many students think the 20 joules belongs only to the 2 coulomb charge. This is absolutely wrong. The correct idea, the one that gets you marks, is that the potential energy belongs to the entire system of interacting charges, not one charge, but the whole setup.
And here's a simple trick to remember this forever. Just think, it takes 2 to tango. You can't tango alone, right?
Same way, you cannot have potential energy with just one isolated charge. You need at least two charges interacting for the system to have potential energy. Remember that.
Okay, so let's quickly pull everything together. We'll summarize what we've learned and also see why this idea is so important for what's coming next.
So, what does this unlock for you? Well, this idea of potential is the absolute key to understanding voltage. And voltage is the foundation of our next big unit, current, electricity. So you must understand this well. Also, there's a key shift happening here. We're moving from thinking about force at a point, which is a vector, to energy over a distance, which is a scalar. And you know what that means? It makes solving problems much, much easier, because scalars are simpler to work with than vectors.
All right, so here are the key takeaways, your final summary. First, electrostatic force is a conservative force, just like gravity. Second, any work done against this force gets stored as potential energy. Third, think of potential as the electrical height, or the energy per unit charge. And finally, the most important one, potential energy is a property of the system, not just one single charge. Got it?
And I'll leave you with a question to chew on. We said that potential is like the height of the hill. So what do you think the slope of that hill represents in our world of electricity? Have a think about that. We'll discover the answer in our next session. Keep studying.